before dawn, in conflict zones across the world, radar operators often hear it before they see it. It's not the familiar roar of a jet fighter or the thunder of a ballistic missile. It's a strange, mechanical buzz, a sound that soldiers on the ground often compare to a lawnmower or a small motorcycle flying through the night sky. That sound belongs to one of the most controversial and impactful weapons of modern warfare, the Shahed-136. But to understand this weapon, we have to forget everything we think we know about air power. This isn't a stealth fighter. It's not a high-tech cruise missile. It looks almost primitive, but its design hides a brutal logic that is fundamentally reshaping the economics of conflict. Welcome back to the deep dive. Today, we're looking at how a cheap, propeller-driven drone became one of the most strategically significant weapons of the 21st century. First, let's be clear about what this machine actually is. The Shahed-136 is what's known as a loitering munition, or more commonly, a kamikaze drone. It's not designed to drop a bomb and return home. It is the bomb. Physically, it's deceptive in its simplicity. It has a triangular delta wing design, which gives it stability and range. At the back, there's a small, commercially sourced piston engine, the kind you might find in a go-kart or a power. Inside the nose, it carries a warhead estimated between 30 to 50 kilograms. On its own, a single one of these isn't a massive threat. A modern air defense system can shoot it down. But that's the trick. You're not supposed to face just one. The power of the Shahed-136 doesn't come from its individual capability, it comes from its numbers. Iranian strategists designed this drone around a concept that is terrifying in its simplicity: saturation. Instead of spending years and billions building a few superweapons, you build tens of thousands of cheap ones. A single shape might be easy to intercept, but 100 arriving at the same time, from different directions. That creates a completely different mathematical problem for the defender. To really understand the impact, we have to look at the price tag. Defense analysts estimate that producing a single Shahed-136 costs between $20,000 and $50,000. It uses commercial GPS, a simple engine, and a lightweight composite frame. It is, for all intents and purposes, a disposable asset. Now let's look at the cost of shooting one down. A missile from the American Patriot system can cost over $3 million. Even shorter-range interceptors, like those used in the NASM system, can cost $500,000 to $1 million apiece. This creates what military planners call cost imposition. Imagine this scenario. An attacker launches a swarm of 20 Shahed drones. The total cost for the attacker is, let's say, $600,000. To stop them, the defender has to launch 20 interceptor missiles. If each of those costs $500,000, the defender just spent $10 million to stop a $600,000 threat. Even if the defense is 100% successful, they lose the economic battle. They are burning through expensive, high-tech stockpiles to stop cheap, simple ones. Over time, this can drain a nation's military budget and deplete its arsenal, leaving it vulnerable to a more sophisticated follow-up attack. The drone itself isn't just a weapon. It's a financial weapon designed to bankrupt the enemy's defense. This brings us to the second pillar of its power: scalability. The Shahed-136 was designed for the assembly line. Its delta wing shape isn't just for aerodynamics. It's easy to manufacture. The airframe is made from composite materials that don't require the complex, slow processes needed for stealth fighters. The engine is a mass-produced commercial item. Because the design is simple, manufacturing isn't limited to one factory. Production can be distributed across multiple facilities. Analysts believe that with sustained production, dozens of these drones can roll off the line every single day. This transforms the nature of the conflict. In World War II, wars were won by the side that could outproduce the other. The same logic is returning to the skies. The Shahed turns a modern high-tech battlefield into an industrial contest. If you lose 50 drones today, you can have 50 more next week. The sky can be refilled as fast as it is emptied. So, how do you use a weapon like this? You don't send them one by one. You send them in a coordinated wave. In a saturation attack, you launch dozens of drones from multiple directions. Some fly high, some fly low to hide against ground clutter on radar. Often, they are mixed with decoys or even cruise missiles. Air defense networks are incredibly sophisticated, but they have limits. Radar can only track so many targets at once. A missile battery only has a limited number of interceptors loaded. Commanders have seconds to decide which dots on the screen are the biggest threat. The goal of a drone swarm is to create chaos to overload the system's brain. In that moment of chaos, while the defenders are focusing on the main swarm, a few drones slip through. They don't need to all get through. They just need one to hit a fuel depot, an airfield, or a command center. The successful strike of that one cheap drone justifies the entire mission. Recognizing this threat, the world's militaries are now in a frantic race to adapt. We are entering a new phase of the technological arms race. On one side, you have the offensive cheap and numerous. On the other side, the defense is trying to get smart and cheap too. This is where directed energy weapons come in. Laser systems are no longer science fiction. A laser doesn't cost $3 million per shot. It costs the price of the electricity to fire it, perhaps just a few dollars. If a laser can track and destroy a drone in seconds, it completely reverses the economic equation. We are also seeing a rise in electronic warfare jamming, the GPS signals that these drones use to navigate, and advanced autocannons that can shred drone swarms with radar-guided bullets. The contest between the Shahed-136 and these new defenses is no longer just about who has the better technology. It's about who can solve the math problem faster. The attacker trying to overwhelm the system with numbers, or the defender trying to destroy them at a cost that makes financial sense. The Shahed-136 isn't just a drone, it's a philosophy of warfare. It proves that in the modern era, you don't need to build the most advanced plane in the world to have a strategic impact. You just need to build a lot of something that works well enough. It has democratized air power, allowing smaller nations to challenge larger powers in ways that were unimaginable 2 decades ago. It has turned the sky into an economic battlefield, where the victor might not be the one with the shiniest technology, but the one with the most efficient supply chain. The question for the future isn't, can we build a better drone? It's, can we afford to keep shooting them down? This is Rana Asif signing off from the deep dive. Let me know in the comments, do you think lasers are the answer? Or will we see drone versus drone dogfights in the future? Don't forget to like and subscribe for more deep dives into the technology shaping our world.